Hi everyone, in this video we're going to look at question rotate list. So we are given head of a linked list and we have to rotate the list by k places. As in this example we can see the list 1, 2, 3, 4, 5 where k is 2. We have rotated the list by 2 places. The 4 and 5th comes in the front and then 1, 2, 3, 4. So let's quickly understand this question. We have given a list 1, 2, 3, 4, 5 and we have to rotate it by k places so that it becomes 4, 5, 1, 1, 2 and 3. Correct? Now what we are going to do is, first of all, we'll understand that k over here is 2. But what happens if k over here was 10? What would happen? It would rotate by 5 places. It will become 1, 2, 3, 4, 5. Then it will rotate by 5 places and it will become 1, 2, 3, 4, 5. So in order to rotated by 10 places, we have to rotate the list twice. But it is not an optimal solution. We cannot, just simply increase the time complexity by rotating the same list again and again. And in the end, we just have to return this answer. So we cannot do that. So what if our k was 7, right? What if our k was 7? This list would get rotated by 5 places, then it would get rotated by 2 places. Then it will return the same thing. As we can see, for k7 and for k2, we are having the same answer, right? For k7 and for k2, we are having the same answer. So rather than rotating the list by 7 places, we can, in case of k is equal to 7, we can just rotate it by 2 places. How are we gonna do this? We are just gonna rotate the list by k places and we're gonna update the k by dividing it by the length of the list. Okay, so first of all, let's see how we'll calculate the length of the list. For calculating the length of this list, we'll have a temporary pointer, which will be at the head, right? Which will be at the head. Now, this thing will be, the last element will be pointing to null, right? The last element will be pointing to null. So our temp is there, our head is this. Temp will start from head and until it becomes null. Until it becomes null, right? Until it becomes null, we'll just keep updating the temp and keep updating the length. Initially the length is 0, temp is over here. We will check, is temp null? No, we'll update the length. Now we'll go to the next element, then temp will be updated to the next element of temp, right? Now is temp null? No, we'll update the length. 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 Is temp null? Yes, we'll get out of the loop, we'll stop it. The length would be 5. Then our k value, we have to update our k value. The k value will be updated by k modulus length, which will give us the remainder. And which will actually tell by how many places we have to rotate the original list. Correct? Now let's write code for calculating the k. And first of all, in linked list, we'll start by the most basic thing, which is solving the edge cases. The edge case over here would be if there is no element in the list, right? If there is no element in the list, or if there is a single element in the list. If there is no element in the list, or if there is just a single element in the list, then we'll simply return that element. Right? Now let's calculate the length of this list. So in order to calculate the length, we'll start by having a length variable and a pointer to the head value, and a pointer which we'll name temporary to the head value. Now we have a temp pointer over here, and until it becomes null, we'll just increment the length and we'll move to the next element. As I showed you in the 5 seconds ago, it's the same thing that we are doing over here. Now we have to calculate the new k value, right? So in order to calculate new k value, we'll take the modulus of it with length and we'll have the actual number of rotations. Now what happens if k comes out to be 0? what happens if k comes out of be 0, which means that in this case k would be divisible by 5. If for example we have to rotate it by 25 places, the modulus will come as 0, so we'll just return this list. We do not have to rotate it. We'll just return the original list, right? So if k is 0, we'll simply return the head. Correct? If k is 0, we'll simply return the head. Now let's see what we'll do. So this is our original list. Now we have to reach up to this value, right? We have to make this 4, 5, 1, 2, 3 null, right? We have to reach up to this value. In order to reach up to this value, we'll make use of two pointers, which is slow and fast. This method is also known as tortoise head method. Now slow pointer is over here, fast pointer is over here. Both of them are on head right now. So what we are going to do is, slow pointer is here, fast pointer is here. First of all, we'll take the fast pointer up to k places. We'll increment the fast pointer up to k places. Over here k is 2. Fast pointer is at head. Now what we'll do is, we'll move the loop from 0 to k. We'll move the loop for 0 to k. Now for 0th index, we'll increment the fast by one place. Now fast will come here. For 1, we'll increment the fast by one place. Fast will come here. Now for 2, is 2 less than 2? No. So we'll stop. Now our fast pointer is over 3. Which has moved up to k places. But what we'll do is, we have to make use of a slow pointer in order to reach this place. For example, we would have had the list this, and the k would have still been 2, right? If the k would have still been 2, then we would have reached up to this place. But we wanted to reach at this place, right? Because we have to rotate the list by this. We have to rotate the list from 5, so we would have reached this place. Now slow pointer is over here, right? Now until the fast gets null, we'll just start incrementing fast and slow both. Now in this case, our fast is over here, slow is over here, right? Now until the fast becomes null, we'll increment. Fast is null, no, we'll increment both. Slow is here, fast is here, right? Is fast null? No. Slow is here, fast is here. Is fast null? No. Slow is here, fast is here. As soon as the next element of fast becomes null, we'll stop. Now fast will come here, right? I can write it. Fast comes here and our slow comes here, which we needed. Let's code this up. So while the next element of fast becomes null, like it's not null, then we'll increment both of them. Fast is equal to fast next and slow is next, right? We'll increment both, and then it will reach its desired place. It will reach its desired place, which will be a new tail. Because the rotated list would have been 5, 6, 1, 2, 3, right? New tail 3 and 4, right? So the new tail would have been 4. We have reached our new tail. What will be our new head over here? Our new head would be 5, which is the next element of slow, right? So we can store this new head. Which is next element of slow. And we have to point this, our new tail, to null. We have to make this list as 5, 6, 1, 2, 3, 4 and null, right? So we have to point the slow to null, right? So we'll just simply point the next of the slow pointer to null. And now we have two different linked lists. One we have is 1, 2, 3, 4 and null, and the other one that we have is 5, 6 and null. But we have to merge these linked lists. This is our new head, right? This is our new head, and we have to merge these linked lists. So what we'll do is we'll connect the next element of fast next element to our original head. The original head was here, so the fast's new element will be connected to the original head. So the next of fast will be connected to our original head, and will return the new head, right? And we'll return the new head, which is 5 6. Then it will become 5 6 1 2 3 4 and null. 1 2 3 4 and null, right? Okay, yeah, 5 6 1 2 3 4 and null. Okay, so over here we have not defined the fast and slow yet. We'll just simply, put this pointers on head as we saw in the document. Let's go ahead and run this and see if it's getting any errors. So okay, we are getting a wrong answer and we are getting an empty output. Okay, let's see what we have done wrong over here. So if head is null and next element is null, we'll simply return the head. Then we have length as 0 and temporary pointer is on head, and we are calculating the length over here, and k is by length. If it's 0, then we'll return the head. We have updated the k, right? Yeah, we have fast pointer, we have slow pointer. Okay, so we missed one step over here. We missed one step, as we discussed, that we have to, the fast should be reached first over here. We missed this step, that we'll start from 0 and we'll go less than k I plus plus, and we'll increment the fast up to the place up to k values. We'll move fast forward by k values, right? By k values we have to move the fast to the next element, right? Now let's go ahead and run this. Okay, so yeah, now it's getting accepted and it's getting run. Let's try and submit this. So yeah, it's actually beating 100% of the users and it's running really nicely. And that's all for this video. Thank you.